This is the introduction video to Python Pandas. Pandas is another library in Python that's mostly used for data analysis. So in our first line over here, we do import pandas as PD. So what this does is that it imports the library pandas, and then we've renamed that library to PD. So now instead of us typing pandas when we want to get a function from that library, we can just do like pd dot and then whatever function we want to use. So next we have the path, and what the path does is that it stores the URL for whatever data set you want to use. So like over here, I have the UFO sighting data set that I'm going to use to explain all of the basic concepts. We also see this .csv over here. That means that our data set is stored in a comma-separated value form. So that's going to be useful in our next line when we make our variable df. df stands for data frame, and a data frame is a two-dimensional data set with labeled rows and labeled columns. So we do df is equal to pd.readcsv, and then we put our path variable in the parentheses. So what this line of code is doing is that it's going into the pandas library and it's doing the .readcsv function, which reads through our comma-separated values file that we put in path. So this is going to output a data frame. So in our next line, we have df.info. df.info gives us like a summary of the data frame that we just made. So for example, if I run this, I see that I get the rows, I get the columns. So the columns are like the different information that's in the data set. So like in this UFO sightings data set, I have like the city that the UFO was seen in, the state, the UFO shape, and much more. Next, if we just output df, so we're just outputting our data frame, we see like all of this information. So like for example, one UFO was sighted in Texas, and then the UFO shape was a cylinder, and we see that we have all of this information. Another thing that I should point out with df.info is that it gives you all the columns, and also it gives you what type of, like, the type that the information is being stored as. So what I mean by that is, if you look over here, the longitude is a float, but interestingly, the latitude is an object, as is all the other type of information that is stored in this data frame. So that's how all the information is being stored, which will be useful because there are some functions that you can only apply on integers and floats, and some functions that you can only apply on objects. df.head, what it does is that we have our df data frame over here. So what df.head is going to do is that it's going to return the first 5 in our df data frame. So if we run df.head, we see that we get the first 5 data. So, and then same thing for df.tail, we're going to get the last 5 rows in our data frame. So these are the last 5 rows in the data frame. But you don't have to just get like the last 5 or the first 5. You can also, like in the parentheses, if you do like 10, you can get then the first 10 rows, and then in tail, if you do like 20, then you can get the last 20 rows. So say you wanted to look at a specific column, that's completely possible. You can just do df and then square brackets, and you put the name of your column that you want to look at. So for example, if we look at UFO shape, we run this line of code, and then we see that these are like the index numbers, And then this is the UFO shape for every single row in the data frame. Another thing that this line of code does is that it tells you what the, like in this example, what UFO shape is being stored as. So in this example, UFO shape is being stored as an object. But if we run this line of code for the longitude, we see that all the longitudes is being stored as floats. So there are a few functions that I couldn't do on floats, so we would have to say like use different commands to convert the float into a string or an object. And we're going to learn that in a more advanced video. So another thing we can do is df, and then you recognize this, I hope, from our previous line of code, which looks at one specific column. And then we do something called .value counts. So what this does is that we have our row of UFO shapes, and so it has every single shape for every single row. And then we do .value counts. What that does is that it's going to take every single unique value. So in this case, every single unique UFO shape, and then it's going to count how many times that shows up. So if we run this line of code, these are all the UFO shapes that showed up in that one data set. So all the different shapes that people have like referred to when they saw the UFO and they were describing how it looks like. So it looks like light is the most popular. So most of the people that reported UFO sightings, they described it as light. So this is always fun to see, like what people described different UFOs as. And then mean, min, max, and median. This is more like math related. So I'm sure you recognize all of these. So I decided to do it on the column longitude. So the mean of longitudes tells us like the average longitude where UFOs are seen. But what happens with mean is that if you have like outliers that are really outrageous, then the mean can be skewed. So if we run this, so this is the mean of all of the longitudes that we have in our data set. And then if we do the column.min, this is the westmost location where UFOs were seen. So if we run this, out of all the data points and out of all the rows and longitudes that we have, this is the westmost location where UFOs were seen, which I find cool to look at. And then you might have guessed, .max tells us the eastmost location where UFOs were seen. So this is the westmost over here, and this is the eastmost. And then when we look at the median of longitudes, it tells us like the middle longitude where UFOs are seen. So now if you have like some outliers, this value will not be affected by this outliers, unlike the mean. So this is like the middle longitude where UFOs are seen. There's also a function called df.loc, and loc stands for locate because it locates all the rows, and in this case, it's going to locate all the rows where in the column df country, so the column country is equal to the US. So pretty much if we run this, these are all the rows where UFO sightings were in the US. So we see that a good amount of the data set comes from the US. So that could be important for any data analysis that you could do. And then we also have plots. So plots are like one of the more customizable things in Python pandas. That's different from Excel because in pandas, plots are more customizable, and you can really like display any information that you want to show. While in Excel, it's more like whatever is built in there, you have to just fit your needs based on that. So here we have df UFO shape.value counts. So again, value counts counts all the unique values in a data frame. So in this case, it's looking at the UFO shape column, and it's going to get every single unique like UFO shape that people describe the UFO as, and it's going to count how many times it was said. And then we also have dot plot. So what dot plot does is that it's just going to plot it. So you can actually customize this in a lot of ways. Like you can change the kind of plot it is, the title, label the X and Y axis, the color. So for example, if I run this, we see that light, again, was the most popular UFO shape. So when most people describe like UFOs as like light, and then we see like flares, crosses, diamonds. So I could also do different kinds of graphs, though in this case they might look a bit messy. So we also have bar graphs. Bar graphs look really nice in this case. So light wins by a lot. So yeah, we can customize the plots in various different ways, and you can import different libraries with pandas, and then we can make different plots based on that. I'll have that in another video as well. Finally, we have dot sort values. So again, we have our value counts on the UFO shape, and then what sort value does is that it can sort all the values from least to greatest or greatest to least. So what we do is that if we put ascending in sort values as false, that means that it's going to go from greatest to least. And if we put it as true, then it's going to go from least to greatest. Or even if we don't put anything at all in the parentheses, it's going to go from least to greatest. So that's all for Python Pandas. I hope you enjoyed, and these are just the basic concepts. There's really a lot more to explore in this library.